Now we will proceed to the special type of problems. Okay, so in the special type of problem, the first problem we are choosing, that is a set square. You can see for the construction of a set square they have given two angles here, 30 degree and 60 degree. Set square of 60 mm longer side is so kept such that the longer side is in HP. So we have to keep the longer side in the HP plane. So making an angle of 30 degree with VP, the set square itself inclined at 45 degree to HP. So we have to draw the set square. So the main thing in this problem is we have to construct a set square. That's it. Other than that, it will be similar to your normal type of problem. Okay. So I'll be showing how to construct a set square here. So the problem is easy. Only thing here is we have to construct a set square. Okay. So how to construct? You can see that first we consider a longer side 60. 60 means 6 blocks. Okay, so longer side 60 I have drawn. Now you can see 30 degree. So this is the internal angle difference, 30 degree. So the external angle it will be 60. Okay. So from here you can mark for 60. Okay. Sorry, it's 30. We have to mark for this point. Mark 30 degree. Okay, 30 degree. Okay. So here, so we have to mark at 60 degree. Okay. So here 30. So this is 30. Okay. And this is 60. So this angle, how much we got? This is 60. So this is what the 30 degree, 60 degree set square. Okay. So in this you see it. So we have drawn with respect to the question given. So we will be showing the dimension. Okay, 60. So we have drawn a with respect to the longer side, and we will be giving the naming for it A, B, C. Okay. To project it to complete the front view. So it is A dash within bracket, B dash, C dash. Now angle of inclination to HPT is 45 degree. So that is A dash, B dash we have taken. The angle how much it is? 45. So mark for 45 degree. Okay. Now we have to cut the arc from A dash to C dash. Okay. Same procedure how we did the normal type. So it is same. Only thing here in this we have to construct this set square. Okay. Other than that everything remains same with respect to the normal type. A, and this point is B, and this point is C. So we will join it. Okay, so now we have to draw the third position, that is inclination to VP, it is 30 degree, marking a reference point. So mark for 30 degree, draw an angle line. Okay, so this is 30 degree. So after this we have to mark a reference point A. Okay, so from A to B we have to measure, we have to copy this diagram over here, that's it. So cut the arc. So this is the diagram, we are copying it. Okay, from now A to C, first arc, and then from B to C. So we get C here. Okay, now we have to join. Okay, so to complete the final position here, so here we get A dash. Similarly, we got B dash here, and C dash we are getting here. So this is C dash. So now we will join to complete the final B. So that's complete the problem. Today we are going to learn another special type of problem on the isosceles triangular plate. Okay, now we will proceed with the question. Isosceles triangular plate of a negligible thickness has a base 25 mm long and altitude 35 mm. So they have mentioned these dimensions: base dimension 25, altitude 35. You know how to construct the isosceles. I will show you how to construct. Now before construction, it is so placed on HP. You can see that is telling that, so it will be placed on HP such that in the front view it is seen as an equilateral triangle of 25 mm side. So it's telling that it will be placed on HP, but in the front view we have to get an equilateral triangle of dimension 25. So with the side that is parallel to VP, with the side that is the side which will be parallel to the VP. Okay, so that will be inclined at angle of 45 degree to VP. So we can see in this question they have mentioned only one angle of inclination, that is 45 degree to VP. So there is no angle of inclination to VP given. Instead of that, they are telling that with the side that is parallel to VP is inclined at 45 degree to HP. So second angle of inclination they have not mentioned. Instead of it, they have mentioned second weave. Okay, the second weave, it is an equilateral of dimension 25 and it is an front view. Okay, so in the front view, so we have to get an equilateral triangle. So now, so before going to the problem, first we have to identify, is it resting on the HP plane or on the VP plane. So for that I'll be doing a trial. Okay, in trial 1, what we do, say this is our XY VP HP. Say we have constructed with the if we placed on the HP plane, what happens? Say this is our isosceles. Consider this is altitude. Okay, top view. So this is front view. Okay, now by inclining this we'll get a here equilateral triangle. We will construct it. Then by projecting here we get the angle. But herein you can see this equilateral triangle we are getting in the top view. Okay, so this is top view. This is wrong because we have to get an front view. Okay, we have to get the front view. So this trial is wrong. So similarly we'll go for the trial 2. So we will try for the trial 2. You can see in this we will construct here. Okay, such that one of the corner touching the it is in the vertical plane, but it is one of the corner it is resting on the XY line. If it is resting on the XY line, means it is touching on the HP also. Okay, it is placed like this. You can see this. Say consider this is horizontal plane, this is vertical plane, and we have placed like this. Okay, like this we have placed like this equilateral triangle. Say, so the equilateral triangle, it is in the vertical plane, but one of the edges, okay, corner, it is touching the base edge, it is touching on the xy line. On the xy line means it is touching the xy line. Okay, so that's how it is. Say this is the front view, then projecting downward we get the top view. Now in this position they have not mentioned the second angle of inclination, so we have to construct a triangle here. Okay, equilateral triangle of dimension 25. Okay, dimension 25 we have to construct. Then we have to, by proceeding like this, by taking this length, we can find out this angle of inclination. Okay, so this trial to it is correct, because you can see this is equilateral triangle, so we are getting in the front view. Okay, and you can see that, so both the conditions we have to match. So it is so placed on HP such that in the front view, so we are placing an isosceles triangle in such a way that it is touching the HP plane. So how it is touching the HP plane? By placing on the xy line, we are making this one of the end touching the HP. So when it is inclined in the second position, it is seen as an equilateral triangle. Okay, so when it is inclined like this, okay, when it will be inclined like this, we are seeing an equilateral triangle of dimension 25. How it is means, say like this. So say, consider this is our isosceles triangle, we have placed like this, and in second position we are inclining. We don't know how much inclination. We are inclining an isosceles triangle here, but in the front view we are getting an equilateral triangle, but we don't know how much angle. So that angle we are going to find out. Okay, so I'm proceeding with the question, so all of you carefully follow it. So this condition is correct, so all of you carefully follow. So first I will draw an xy line. So drawing the xy line is compulsory. Okay, VP, HP. So first I'm constructing isosceles triangle. First I consider base edge, that is 25. Okay, so after constructing base edge 25 exactly, I will show the dimensions initially. Okay, so exactly at the middle of this we have to consider a center point. So it is exact 25 means it is 12.5, somewhere here we get. Okay, 12.5. to this 12.5 we have to mark altitude. Okay, altitude of 35, straight line, horizontal line of dimension 35, exactly 35 you have to draw a straight line. Okay, then after drawing 35 you join this. Okay, so this is what your isosceles triangle. So we are giving the naming A dash, B dash and C dash. Okay, so when we draw the top view of it, so we'll get it on this xy line only. Okay, so it is A and B will be in bracket and C. So this is what the top view. But in this second position, angle of inclination to VP they have not mentioned. Instead of that they are telling we get an equilateral triangle of dimension 25. So I'll be drawing an equilateral triangle here by taking 25 dimension. Okay, so this problem is a little bit different, that's why we call it as an equilateral triangle, special type of problem. Okay, so we know how to construct equilateral triangle, dimension 25. So in this problem they will be not mentioning one angle, instead of that they will be telling one view. Okay, so in this we are getting a front view. Okay, front view. So in the front view we are getting an equilateral triangle. Okay, so it is A dash, this is B dash and this is C dash. So this is a equilateral triangle, but we need to find out how much inclination we get it here, how much tilt we have to do this isosceles triangle such that we get a equilateral triangle here. Okay, for that I'll just drawing an projection line here. Here at this point I will take a reference point here, A of B, then measuring this line A to C, I'm measuring this length A to C, measuring this length A to C. I'm going to cut the arc. Okay, so so now we can find out how much angle of inclination it is. So herein I'm getting around 50 degree. You have to get 52. Okay, 52. So I'm getting 50 degree. Okay, so now we have done the second position. You can see in this problem how it is proceeded: 1, 2, 3 and 4. First we have drawn this, second, third and fourth. Now fifth. You can see in this question, with the side that is parallel to VP is inclined at 45 degree. So this is what A dash, B dash and this is what parallel to the VP. Now we have to incline this end. Okay, we have to incline this end by an angle of 45 degree. So how we do that? So here we marking a point of B dash. Okay, so here at this point I'll be taking an angle of 45 degree. Okay, drawing a line. Now measuring this end, because this is what the end A dash B dash end is parallel to VP. So I'm going to cut the arc. So this is A dash. Now similarly with the same length we have to construct a triangle, same dimension 25. Okay, it is already measured 25. Okay, now we join this. Okay, you can show the angle here, it is 45 degree. So now we can write the notations. So here I am getting A and this point is B and this point is C. So join it. Okay, so these are completed. This fifth, sixth. Actually this problem it is proceed like this. Okay, like this in the arrow direction. Say first we constructed this, second position, third, fourth, fifth, sixth. In this problem they have mentioned only one angle, that is angle of inclination to HP. They have not mentioned the angle of inclination to VP. Instead of that they have mentioned one V, that is equilateral triangle of dimension 25. So this is all like this. Okay, good morning. We see another type of different type of problem in pentagonal lamina. So you can see in this question a pentagonal lamina of dimension 25 is having a side both on HP and VP. Okay, we have to make sure that one of the side has to touch both the HP plane and VP plane. Okay, so that's what the condition. The corner opposite to the side on which it rests is 15 mm above HP. That means it is indicating the second position. So drawing a 15 mm line and drawing the locus, so you can construct the second position. So you can see in this question they are mentioning we have to make sure that one of the edge has to be there in the HP plane and one of the edge has to be there in the VP plane. So you can see with respect to the condition I have drawn the edge AB, it is resting on the HP plane. Okay, and second angle of inclination is there with respect to 15 mm above HP. Now the third position we have to go with this condition. A side has to be there on both on HP and VP. Now the side AB it is already there in the HP plane. We have to make sure this AB plane has to be there in VP. How to do that? We will take this AB edge and has to touch the XY line. By touching this AB edge, touching the XY line, we are making sure this AB edge it is touching the VP plane. Okay. First I will take a reference point of B here. From B to A. So this is the length. So we have to transfer this diagram with respect to BA. These two lengths will be same. Okay. Now reverse it is. Okay, so reverse we have to touch it. So after this we have to transfer the diagram. Measuring this length E to D, so this length is exactly equal here. Okay, so this is C, this is D, and this is E. So join all these points. Okay, so now projecting upward we can complete the rest of the diagram. So we have B dash and A dash here. Okay, and similarly we have this is C dash, this is E dash, and this point is D dash. So these are we complete the problem. You can see that we have to make sure the side both on HP and HP VP means the side it is there in the HP plane. Okay, now we are making it touching the VP plane. Okay. We see a different type of problem in hexagonal lamina. You see, in this problem we have to construct a hexagonal lamina of dimension 30 is resting on HP with one of its corners in VP. Okay, it will be a different type, and the surface inclined at an angle of 30 degree to VP. The diagonal, okay, the diagonal passing through the corner which is in VP, appears to be, they have mentioned appears to be, so means means no beta angle. Okay, and then they have mentioned inclined at 40 degree to HP. So in this problem you may be coming across, so it is resting on the HP plane with corner. So we see with the trials here. Okay, trial 1, just a rough sketch. XY, say it is resting like this, first position. Okay, first position, inclination to HP given 40 degree, and here we get another diagram here like this. Okay, so this is the diagonal, but you can see in this question the diagonal passing through that corner which is in VP. So this is our diagonal. So this diagonal, it is there in the HP plane. Okay, so with the question it is telling which is in, okay, the diagonal passing through that corner which is in VP. So that means this diagonal has to be there in the VP plane. That means this triangle, this trial, it is wrong. Okay, so this trial, you can see that. So in this problem we run the first trial, so resting on the HP plane, corner touching the VP. So inclination we have mentioned. Now with the second condition, the diagonal passing through that corner which is in VP. So this diagonal, it is not there in the VP, it is there in the HP. So that's why this trial, it is wrong. Now we see the trial 2. So in this trial 2 we are going to construct like this, on edge touching the HP plane, corner it is in the VP plane, the first position. Okay, and then inclination, it is inclination to VP given, so you get it like this. Okay, second inclination, and third inclination, you can see this is what our diagonal. So you can see here diagonal, it is there in, is in VP. So this trial, it is correct. So we will proceed now with the solution. Okay, so we have to get hexagon here, hexagon of dimension much 30. So I'm going with another method, that is measuring 30 mm and drawing a circle, so it will become easy to construct it. So drawing a circle here, okay, so herein we have to construct like this, right? So for that I'll be drawing like this, initially 30 mm line, edge, okay, edge with the dimension 30, and then measuring for 60, angle method only will do it. Okay, so 60, marking the angle and draw a line. Similarly here also we will do with the same procedure. Here 60 in this direction. Okay, now we have to cut it at 30 here, right? 30 mm. Okay, so we have 130. Now again to this point, we have to merge this line. Okay, again we have to mark at 60. Okay, so again 60. So already we have measured at 30. So I'm cutting the arc. So now we have to join it. Okay. So this is what A dash, B dash, C dash, D dash, E dash, and F dash. So it is having a dimension of how much? So 30 it is. Okay. So the top we get it here on this line, on the XY line. Okay. So this is B, C, F, A, D, F, F, E, right? So the second angle of inclination, that is inclination to VP, they have mentioned 30 degree. First we will mark a reference point here. So to this reference point we are taking an angle of 30 degree. Okay, now we have to cut the arc from B to E. Okay, from B to E we have to cut the arc. So this is B and this is E. The another arc we have to cut from B to D. Second arc, third arc from B to C. Okay, so this is C of E, this is D of S, is 30 degree, right? So we are going to dark this length. This is what the thing which is important. So now we will project it upward to construct the second position front view. So here we get here B dash, and here at this point we have A dash. Okay, and this is we have F dash, this is F E dash, this is D dash, and this is C dash. So we have to join this. Okay, now you see the question, we have to take the diagonal passing through that corner which is in VP. So this is what the diagonal which is there in the VP, right? So this is the diagonal in VP. So we have to incline at an angle of 40 degree to HP. So what we do, so here it appears to be no beta angle. So we'll take a reference point. Okay, and the angle of inclination we take here is 40 degree. So 40 degree we have taken. Okay, so now we have to take this B dash. Okay, so we have to place it with respect to the diagonal. B dash, B dash, B dash, E dash. B dash, E dash we have put it. Now from There are two arcs we have to cut, then another two arcs here. Okay, so now it is reverse. So now it is cutting here. So now we have to join this. Okay, this is C dash, D dash, C dash, F dash. Now projecting downward so we can complete the final position here. Okay, so we get B here. Okay, so we get C here, and we are getting D point here, and we are getting E here. This is F. Okay, so the E point we are getting here. Okay, so we have to join this. So this is how we complete the problem. Good morning. We see a different type of problem in hexagonal lamina. You see the question. So we have to construct a hexagonal lamina for dimension 30 mm, lying in such a way that one of its sides touches both the reference planes. So it is somewhat like a similar pentagonal lamina problem in which one of the side has to touch both HP plane and VP plane. That's what. That says that one of its side touches both the reference planes. The side opposite to the side, if the side opposite to the side on which it rests is 45 mm above HP. So see that this is what the side which is opposite to this side, it has been inclined at a height of 45 mm. Okay, so that's how we get the second position here. They have not mentioned any kind of inclination here. Instead of it, for the second position they have mentioned this sentence, that is side opposite to the side on which it rests is 45 mm above HP. So what we do after completing the first position, we draw 45 mm line and draw the locus. Okay, after that I will be making a reference point. Okay, then measuring the length from B dash D dash, I am cutting the arc. Okay, then after cutting the arc I will be joining a line here. Okay, after that I will be measuring again from B dash to C dash and then cutting the arc on this line. So this is how we draw this second position. Now you can see in the third position we have to make sure such that the side should touches both the reference planes. Both the reference plane means both HP and VP. Now it is there in the HP plane. What we do that, we will take this AB end and we make touch the XY line, thereby making touching the VP plane. Okay. So for that we will be taking a reference point of here B. So B to A. Okay. B to A it is. Now cutting the arc length from A to F. So these two lengths will be same. Okay. Okay, now it is reverse. A to C. So here we have to cut. So we are not cutting, so we'll measure again A to F. So it is getting here, it's getting here. Okay, we're getting 2 points here. This point is C and this point is F. Again from F to E, we have to measure this point. F2 is over. Now reverse it is from F to D. Okay. So this point is D and this point is E. Okay. This it is touching at this point. Okay, so now you see that this is the end AB which is touching both the HP plane and the VB plane. Now we'll project upward to complete the final position. Okay, so here this is B dash, A dash, C dash, F dash, D dash, E dash. So you can join it. Okay, so this is what completes the problem. Problem number 47 of CAD solution book. In this problem you can see that they have given circular lamina of diameter 50. So standing with one of its points on the rim on HP. So it is resting on the HP plane. The lamina is inclined to HP at 45 degree and that is the second angle of inclination. The diameter at right angles to the diameter which is passing through the point on which the lamina rests is parallel to VP. So we have to make that diameter parallel to VP. So that is what our third position. Okay, first we need to construct a circle here. Circle of diameter 20, diameter 50 means, so radius we have to consider 25. Okay. So circle it is drawn. Now we have to divide the circle into 8 equal parts. Degree, 135 degree. So you can extend. So it is divided into 8 equal parts: A, B, C, D, E, F, G, H. Plus 50. So project it upward. Dash, dash, C dash, C dash, B dash, B dash, and F dash, and V dash. Take your dash. The angle of inclination to HP 45 degree. So we'll take 45 degree here. So marking at 45 degree. We can give the namings here. B, C, D, E, F, G, H. So now we have to go on a list. So ellipse is constructed. Now we have to make this, okay, this the diameter we have to make it parallel to VP. Okay, parallel to VP, we have to make it. So take here, this is V. This encompass everything. We have to copy this diagram. This is V. Exactly the point. D dash, D dash, so this completes the problem. Okay, we see a special type of problem in circular lamina. You see in the question, a circular lamina is inclined to the VP, appears in the front view as an ellipse. So the first position will be an circle. When it is inclined to the VP, it will become an ellipse of major axis 30 mm and minor axis 15 mm. But in this question, you see it, they have not mentioned the circular lamina dimension. So what we do is we consider major axis dimension 30. By taking 30 mm, I will be constructing a circle of diameter 30. Okay, so that's how first position and second position. Then after that, you see major axis is parallel to both HP and V. We have to make major axis parallel to both HP and VP, and one end of the minor axis we have to make major axis is in both HP and VP. So what I will do in this question is, first I will be constructing a circle by considering major axis. Okay, VP, HP. So herein I'll be, so diameter 30 means the radius will be 15, correct? So radius will be 15, diameter 30 means radius will be 15. So from this point you can say where it is touching the XY line, here, exactly here we will drawing. Okay, like this we have to draw a circle for dimension 30. So we can show the dimensions above here. Diameter 30. So what we do here is we are going to divide this circle only 4 parts, not the 8 parts here in this special type of problem. Okay, so we are dividing the circle into 4 equal parts. So we are giving the namings A dash, B dash, C dash and D dash. And here by projecting this we are getting a top view here on this XY line. Okay, so here we have A, the B it is in bracket, D. Okay, so B it is in bracket, D and C. Now we know that the second position it will be an ellipse, okay, of major dia 30. So directly we are doing it. So I am drawing a major dia 30. Next, exactly from the center we know that minor axis is 15. 15 means exactly at this point 7.5 we have to consider. 15 half, it is 7.5. So for 7.5 we have to end here. Okay, for 7.5, so marking at 7.5 on both sides. So you can see that these are major axis, these are minor axis. Now with respect to this we have to draw an ellipse here. Okay, so this is what the ellipse with a major axis 30 and with a minor axis 15. So this is our A dash, B dash, C dash and D dash. So we don't know how much angle it is. To find out that, we are going to extend it. Okay, so extend it. This is A, measuring from this end from A to C. I'm gonna cut the arc. Okay, so this point is C. I'm gonna draw a line, okay, angle line. Again, there are two arcs here, right? From A to B also I'm cutting the arc. Okay, so this is B of D. So we can measure how much angle it is. So the angle we get it here, it is around 60 degree. Okay, 60 degree we are getting. Now you see the question. So the major axis has to be parallel to both HP and VP. So this is what the major axis. Okay, this is major axis and this is minor axis. So this major axis now it is parallel to VP. So we can make a parallel to HP means like this. So you can see this one end of the one end of the minor axis is both in HP and VP. Now one end of the minor axis it is in VP. Now we have to make it in HP means we have to touch this point. Okay, so how we do that? So I will take this reference point A dash here. Okay, one end of the minor axis and drawing 15 mm. Okay, drawing exactly 15 mm. Okay, so drawing exactly 15 mm now. So we have drawn exactly 15 mm. So now I have to consider exactly half part of it. Okay, that is 7.5. We have to mark 7.5. So I marked. Now from this exactly 7.5 we have to mark 15 mm. Okay, 15 this side for to construct a major axis, right? Okay, so major axis. Now we can draw here. This is C dash. So this will become D dash and this is B dash. Now ellipse we have to draw here. It has to be a smooth curve. Okay, so this is what we complete the third position. Now final position, it is just extending. Okay, projection lines. Okay, now here we get A. So this point is D, this point is C, and this point is B. Correct. So this is B dash. So now here again we get a circular ellipse here. So make sure you draw with a smooth curve. So this is how we complete the problem. Problem number 50 from CAD solution book. You can see in this problem, so they have given a circular lamina of 30 mm diameter rests on VP. So first position starts from the VP plane such that one of its diameter, so they mention one of its diameter is inclined at 30 degree to VP and 45 degree to HP. Okay, 45 degree to HP. This is HP. So you can see that they have mentioned one of its diameter means it's an beta angle problem. Okay, so in this problem our first position starts from the VP plane. Okay, So diameter 30 means we have to consider a radius of 15. Okay, 30 mm. So 15 diameter. So we have to divide the circle into 8 equal parts. Dash, dash, slash, U dash, dash, F dash, H dash, H dash. I can show the dimension. So by projecting downward, we can complete the top view. So inclination to VP we have 30 degree. Inclination to VP 30 degree. BFH inclination to HP 45 degree. So inclination to HP is 45 degree. So now it is an beta angle problem. We have to use these diameters. Take a fade brush. First diameter length will be this. Second I'm going to use this. Okay. Now we have to transfer this diagram over here, okay, using arc method. Okay, this completes the problem. Okay, we will learn another type of problem in rectangles, that is shorter edge and longer edge problems. Okay, in the shorter edge problems we have shorter edge problem. You can see this, we have two types of problems in rectangle. One is shorter edge and longer edge. So if it is in the problem they have asked to construct a shorter edge problem, means we have to consider a shorter length in the rectangle for the first position. Similarly, if they mention a longer edge in the question, we have to consider a longer edge in the first position. Okay, so that's what the first positions in the shorter edge and longer edge problems. Today we are going to learn another problem on longer edge. So you can see in the question we have to construct a rectangular lamina of dimension 20 mm into 30 mm. So rests on HP on one of its longer edges. So this problem belongs to the longer edge problem in a rectangle. The lamina is tilted about the edge on which rests till its plane surface is inclined to HP at 40 degrees. So inclination to HP given, and the edge on which it rests is inclined at 30 degree to VP. So both the inclinations were given. Only thing is we have to construct an rectangle with respect to the longer edge here. Okay. So we have to construct a rectangle here with respect to the longer edge. Here 30, longer edge it is 30. So 30, 20. So this is A, B, C and D. Okay, so we construct the front view now. So here we got the B dash, C dash, A dash, D dash. So inclination to HPT is 45 degree. Take a reference point B dash, A dash. So marking at 45 degree. Okay, so we have to cut the arc from B dash to C dash. So this is C dash and D dash. So the angle we are getting here, it is 45 degree. So here A, B, C and D. So this is what the second position top view. Okay, now inclination to VP is 30 degree. Take a reference point here. It is 30 degree. So I'll take a reference here A. Okay. Measuring the length from AB. So AD and BC, these lengths will be same. Now it is reverse. A to C and B to D. Okay, now we will project it upward to complete the final position. So here it is A dash, B dash, C dash, D dash. So this we complete the problem in the longer edge in rectangles. Today we are going to learn shorter edge problem in rectangles. Okay, so we have to see the question first. You can see this rectangular lamina of dimension 35 into 20 mm. So we have to construct a rectangle of dimension. This rests on HP, so it is resting, first position resting on the HP on one of its shorter edges. So we have to construct an rectangle with the shorter edge here. Now the lamina is rotated about the edge on which it rests till it appears as a square in the top view. So it is similar to your isosceles triangular problem, wherein the second position is an equilateral triangle, right? Similar to it, herein they have not mentioned the angle of inclination to HP. Instead of that, they have mentioned a second position V. Okay, in the second position top V, we getting a square of dimension 20 we can construct. Now the edge on which the lamina rests is inclined to VP 30 degree. Okay, so in this first we have to construct a rectangle. Next, in the second position we will get a square of 20. Okay, and in the third position we have to incline it by 30 degree to VP. Okay, so we'll proceed with the question. So XY VP HP. So our first position start from the HP plane with respect to shorter edge. Shorter edge means here it is 20 mm. So I'll be taking 20 here. So this is 20 and here it is 35. 35 means 3.5 box. Okay, 3.5 box. This is 20. This is 35. Okay, now we can write the notations A, B, C and D. So we'll draw the front view. Okay, so B dash and C dash visible, but A dash and D dash not visible. So you can see in this problem they have not mentioned the second position. Instead of that, they have mentioned we get a square in the top view. You can see that the lamina is rotated about the edge on which it rests till it appears as a square in the top view. So if we project it here, we get a square here, dimension of 20 here. See, so if we project it, we will get a square of 20 here. Okay, so we'll get a square of 20 here, dimension. So first we will construct this. So it is similar to your isosceles triangular problem. Okay, so here it is A, B, C and D. Okay, now projecting it upward, we'll get the inclination to HP. Okay, so how much we have tilted the rectangle such that we get an angle here. Okay, so this is the reference point B dash, A dash. So we're measuring this length. Okay, it is similar to your isosceles triangular problem. measuring this length, we are going to cut the arc. So we'll get angle here. So C dash and D dash, we have to find out how much angle it is. Okay. So you can find out how much angle. So it is around 55 degree. Okay, 55 degree it is. Okay. So now in the third page you can see that the edge on which the lamina rests is inclined 30 degree to VP. So we have to first take a reference point. To this reference point, drawing 30 degree angle line. Okay. So 30 degree angle line. So we have to place this resting edge on this angle line, that's it. So take a reference of A. Now A to B, cut the arc. Next from A to D, this is also same, right? All are 20 mm only. So this is B. Now reverse, A to C and B to D. A to C. Okay. Then B to D. So this is D and this is C. Okay, now projecting upward, we can complete the first problem. Okay, so we get it here. This is A dash. So B dash we get it here. C dash is this and D dash is this. So we'll join these points to complete the final position. Okay. So this is how we complete the shorter edge problem in rectangles. We see another type of problem in rectangular lamina. Okay, in this problem also they have not mentioned any kind of inclinations. So based on the question we have to proceed with the solution. Okay, you can see in this question, first we have to construct a rectangular lamina of dimension 20 into 25 has an edge. So you can see in this problem, constructing a rectangle 20 into 25 has an edge in HP and adjoining in edge in VP. So that's what our first position. It is tilted such that its front view appears as a rectangle of dimension 20 into 15 mm. So that's what your second position. Okay. So now I am drawing the first position. So you can see in this first we have to construct a rectangle of dimension 20 into 25. VP HP. So here you can see that we need to construct a rectangle of dimension 20 to 25. We know that, so it will be there in the vertical plane because the next view is in front view, correct? So how we have to proceed? You can see that one edge has to be there in HP, another adjoining edge has to be there in VP. So what I will do, I will be drawing one edge that is 20, that is touching the vertical plane, another edge of dimension 25. So I am starting with the VP here. Okay, so you can see that 20, 25. So you can see in this problem, so one edge is there in the HP plane, another adjoining edge it is there in the VP. So based on the question, has an edge in HP, okay, and adjoining edge in VP. So both the things are done. So now we'll show with the dimensions. it is 20, this is the 25. Okay, this is A dash, B dash, C dash, D dash. So here you can see that A, B, D, C. So this is what the front view. So front view also we get it on the same line. So we are done with the first position. Now we see that, so such that it is tilted, its front view is a rectangle of 20 into 15. So what we do in this problem is, it is like this. Like this. You can see that this like this. Say this is our first quadrant. Like this we have placed the lamina, and then we are tilting like this. Okay, tilting like this, such that we get another rectangle of 20 into 15. So another rectangle of 20 into 15 we have to get it here. So if we project it here, okay, if we project it here, we will get a 20. So that means one edge we get it here, that is 20. Okay, another edge we get it, that is 15. 20 into 15 you can see in the question. So 20 into 15, 20 into 15, that is A dash, B dash, C dash, D dash. So this is what 15 and this is what 20. Okay, it's 20 and this is 15. Okay, so this is dimension 15, this is 20. So now we have to project to get the angle here. So we have, this is what E of B. So measuring this length from here to here, we can cut the arc. Okay, this is D of C. Then you can join this, can find out angle here. So the how much angle we will get it here, we'll check it. So the angle we are getting, it is around 53 degree. Okay, 53 degree. Now you see in the question, the edge which is in VP is 30 mm from the right profile plane. The edge which is in VP, right profile from the, so which is 30 mm from the right profile plane. So this is what the edge which is there in the VP, because A dash, B dash, A dash, B dash. So from this end we have to count 33 boxes. Say 3 boxes. This is 30, and exactly here we have to construct an x1 y1 line, x1 y1 line to find out the other view here. Okay, side view. So here I will be marking at 45 degree. To get the side view we have to draw 45 degree angle line, correct? So this is 45 degree. So now I can project, okay, project it from both sides. I can see that where we get D and C. So D double dash here we get, and C double dash here we get, and then here you can see AB from this end, and we have AB. So A, it's the B double dash we get it here, and this is B double dash. So this is what was side view. So this completes your problem. So based on the question we have proceeded, right? So you can see in this question also they have not mentioned any kind of view here. Okay, any kind of view. So this is RPP, so this is left side view. So based on the question we have done this problem. Today we are going to learn another type of problems on rectangles. You see in this problem, the top view of a square lamina of side 30 mm is a rectangle of side 30 into 20 mm. So it's like your isosceles triangular problem, wherein first we have to construct a square here, square of dimension 30, and your second diagram will be a rectangle. Okay, After that we have to proceed with the longer side of the rectangle being parallel to both HP and VP. So you can see in this problem they have not mentioned any kind of inclinations. Okay, there are no inclination to HP or VP. So based on the question given, based on the questions, we have to do it. First thing is we have to construct a square lamina of dimension 30. This is the top view. So top view of a square lamina means first projection will be in square, second will be in rectangle. Okay, rectangle of side 30 into 20. Instead of giving an angle, they mentioned the views here. Okay, first I will proceed with the question here. Okay, so you can see in this, first we have to draw an XY line. Okay, XY, VP, HP and Y. First we have to construct a square of dimension 30. Square of dimension 30 I want to construct. That is 4 boxes. Sorry, that is 3 boxes, right? So dimension 30 here. Square of 30 we have to construct. So this is our top view, A, B, C and D. So it is 30 mm. So the front view, what we get here, so front view we get it on this line. Okay, so that is B dash, C dash visible, but A dash and D dash not visible. You can see in this problem we have to get a rectangle. They have not mentioned any kind of inclination. Instead of that they have mentioned a one weave, that is rectangle. So in the second position we are going to incline the square lamina such that we get a rectangle here, rectangle of 30 by 20. If I project from this side, okay, project from this side, so we will get a longer side of 30. Okay, we'll get a longer side of 30. So first I will get draw 30, then 20. We have to construct here 30 by 20, right? So 30 by 20 is the rectangle, that is A, B, C, D. 30 by 20 rectangle. So we can show the dimensions here. So this we know this is 30 and this is 20. Okay, now we have to find out the angle of inclination. How to do it? Just projecting the lines upward here. Okay, so take a reference of here, this B dash and A dash reference. So by measuring this length from this B dash to C dash, okay, so we are going to cut the arc. So this is C dash and D dash. Now we have to join this after cutting the arc. Then we will find out how much angle of inclination here. So herein I am getting around 48 degree. Okay, so this is what the first position. Second, now we have to see, you can see in the question the longer side of the rectangle being parallel to both HP and VP. So longer side of the rectangle, so this is what the longer side of the rectangle, right? 30 mm. This is what you have to make it both parallel to HP and VP. So in this position it is parallel. Okay, it is parallel to HP. Now we have to make it parallel to VP. How to make it parallel to this? What is this at AB? It is parallel to HP now. Okay, so this position it is parallel to HP. How to make it parallel to VP means we will take this AB side here like this, we'll draw like this, so that will become parallel to VP. So you can see in this here it is 30, right? So 30 right here, 30 by 20, right? 30 by 20 rectangle. These are 30 by 20. So this is B, A, T, C, correct? So yes, so we have done. So now we can see this AB end, which is parallel to HP, now it is become parallel to VP here. So now we will project it upward to complete the final position. So in this you see it, so B dash not visible, and C and we have C dash, we get it here, and D dash we are getting here, and A dash we are getting here. So this is what the actual final view. Okay. So now you can see in this question, draw the top and front views of the lamina. You have to find out the inclinations, okay, inclinations of the surface of the lamina with HP and VP. We got one inclination, that is inclination to HP. To find out inclination to VP, what we do, here in first we will draw an x1 y1 line, okay, x1 y1 line, okay. We'll draw 45 degree angle line here to this reference point, to this point, okay. So this is 45 degree angle line we will draw. Then we have to start from this top view until it touches the 45 degree angle line, okay. Then we have to project it upward. It is touching, okay. So then from this front view also, so we have to project. Now we have to see where the top view notations and the front view notations are merging. Okay, here we get, you can see that here, exactly here at this point, we have B double dash and A double dash. Similarly here exactly at this point we have C double dash and T double dash. So this is what our side view, okay. This is what our side view. Now we can find out, this is what the angle of inclination to HP, this is what the angle of inclination to VP. So if you just measure it, so already we have got this is 48 degree, right? This is 48 degree, so this is 42 degree. 48 plus 42 means 90 degree. So this is how we completed the problem, okay. Parallel to HP here, now it is parallel to VP. That's how we have proceed in this problem. Good morning. We see another problem in rectangular lamina. Okay, we see the question in this. So what is given in this question is the front weave of a rectangular lamina of sides 13 to 20 mm is a square of 20 mm side. So that's it. They have given only this thing. The front weave of a rectangular lamina 30 mm into 20 is a square of 20 mm. Draw the projections and determine the inclination of the surface of the lamina with HP and VP. So in this problem they have not mentioned either any of the inclination to the HP or to the VP. They have mentioned only the second wave. Second wave will be in square, okay. So that is occur only in the front view. So this problem will be proceed with respect to the differently. So I'm just going to show it how it is. Say if you consider this is your first quadrant, so the lamina will be placed like this, okay. Lamina will be placed like this, and the inclinations, okay, the inclinations what we give, okay. So what we give, it will be like from this end, say it is like this, so it will be fixed to the one end in the first position, the second inclination like this, okay. So the inclinations we can see only with respect to the side view. For that we will be drawing an x1 y1 line, okay. So x1 y1 line will be drawn in this, and we are going to find out, okay. So this problem will be proceeding like we say, just show it how it is. VP HP. So here we draw, okay, rectangle of dimension 30 to 20. So the first view, second view, get it here. So in order to find out the inclinations, what we do, we will be drawing x1 y1 line here, and we will be drawing 45 degree angle line and then projecting it here, we get the angles. Okay, so that's how the problem proceeds. Okay. X VP. So in this, first we construct a rectangle of dimension 30 into 20, that is 3 boxes. 30 into 20. Okay, so this is A dash, B dash, C dash, D dash. So the top view we get it on this XY line only. Okay, B, D, F, C. Now the second view is a square. Okay, square of dimension 20. So we will construct that is 2 by 2 box. Okay, so we can show the dimensions here. So this is 30 and this is 20. Okay, and also 20. So 20. So this is A dash, B dash, C dash and D dash. So herein we have to find out the angle of inclinations. Okay, so how we find out here is we will be drawing in here x1 y1 line. Okay, x1 y1 line, and we are going to project these side views. Okay, project these side views. Okay, how we do it? Like the side view of this lamina first position will be lying on this x1 y1 line. Okay, so that's what the side view of this first position. So what we get here is A double dash, D double dash, B double dash and C double dash. This is what the side view of the first position. Similarly for the second position, so what we have to get the side view here is, so projecting here, so we know that, so this is what the first lamina, by inclining it how much angle we don't know, we're getting a square of 20 by 20, right? So this is what has been inclined like this. So it has been inclined like this. Say this is our first quadrant, means say this is our rectangular lamina and this has been inclined like this. So right, it has been inclined in such a way that we are getting a square of 20. So whatever the inclination is there, we can show it in the side view. Okay, how to show it in the side view means, so say this is what the side view of the first position, A double dash, D double dash, B dash, right? So this is what the side view. So this side view we are going to incline it with the help of arc. Okay, with the help of arc. So here exactly at this point we are getting the side view of the second position. Okay, so this is what the side view of the second position. Okay, so now we can get the angle here. So this is what the angle for the both the inclinations. So we can write down this. So the one angle of inclination here, it is 42 degree and this is 48 degree. Now we have to draw the top view of this. So what we do for that, we will be drawing an angle line here. 45 degree we have marked angle line. Okay, so we're projecting it downward. We get the another view here. Okay, so here we get it A, D, B, C. So this is what we completed with the problem. Okay, so in this position first we have drawn this one, and top view. Second, after that we have drawn this one. Okay, then after that we have drawn an x1 y1 line to draw the side views. The side view of this, it is falling on the xy line, and the side view of this, it is falling here. By taking this, because we are inclining this in such a manner that we are getting the top view. So that's why we are inclining it by means of an arc here. We'll be showing the direction of the arrow mark. Okay, inclining it by cutting the arc, we are getting the side view of this position. So by doing it, we get the both angles for the angle of inclination to HP, angle of inclination to VP. Then the top view of this position we are getting by drawing an 45-degree angle line. Okay, so drawing an 45-degree angle line, we are getting the top view of this position. Okay, now we are going to learn the concept for beta angle problems in plane surfaces. Okay, so how to identify a particular problem is beta angle or not. Okay, so you can see in this, if any one of the angle of inclination with respect to HP or VP, any one of the angle of inclination, so you can take either the inclination to the HP or VP. If it is there with, you can see these words are important: median for triangle, diagonal for square, perpendicular bisector for pentagon, and diagonal for circle, and diameter for circle. Okay, diameter for circle, if it is given, then it is called as beta angle problem. You can see in these diagrams, for a triangle, a line drawn from this corner point to the exactly middle of the this side, we calling that is a median. Okay, for triangular type of problem, he will be mentioning a word called median. Okay, similarly for a square problem, he will be mentioning a word called diagonal. Okay, diagonal will be there connecting the corner 2 points, so he will be mentioning that. So that is indicating that it is in beta angle. Similarly for pentagon, we have perpendicular bisector. If this word is mentioned, means it is an beta angle. Similarly for hexagon, they will be mentioning a word called diagonal. Okay, if that particular word is defined, means it's an beta angle. Similarly for the circle, you can see this circle, so there will be diameter given. The angle of inclination will be given with respect to diameter, any one of the angle of inclination. Okay, either with respect to HP or with respect to the VP. So that's how we can identify it is an beta angle problem. So remember it, any one of the inclination either to the HP plane or to the VP plane, if it is mentioned with respect to median for triangle, diagonal for square, perpendicular bisector for pentagon, diagonal for hexagon, and diameter for circle given, then it is an beta angle problem. Okay, in beta angle problem, you see this, the first two positions will be remaining same. So that's why I have drawn the first two positions here. You can see equilateral triangular lamina of dimension 25 lies on one of its sides on HP. So we have constructed the first position top and front view. Next, the lamina makes 45-degree with HP. So 45-degree inclination also we have shown here. Now you see the only change with respect to normal type problem and this beta angle is, so it is changed only with respect to the third position. So first two positions will be remaining same. That's why I have drawn initially these two positions. Now we have to construct the third position. So that is one of its median is inclined at 40-degree to VP. That is, so you can see here the median, it is given for an equilateral triangle. So it is an beta angle problem. So what is the procedure here? So please you follow it. First I'll marking a reference point, and then keeping at this reference point, I'll be marking at 40-degree because angle of inclination to VP it is 40-degree. So I'll be drawing an angle line here. Okay, so this is having angle of inclination 40. So after this drawing angle of inclination, what we have to do is we have to draw the medians here. Okay, median length. So median length, it is starting from this point to here, horizontal line. So this is BD1. Okay, now similarly we have second median length, that is we have second median length from here to here. Okay, that's what the second median length. So this is BT. So we have two median lengths. Initially what we do, we mark a point of B here. First we are going to measure this first median length, this is second median length. Okay, there are two medians, one is BD1 and second one is BT. First we have to use this BD1. Okay, using the compass we are going to measure this length. Okay, we are going to measure this length. Now cut the arc. Okay, So this is PT1. Okay, after cutting the arc, what we have to do is, using the scale, we have to draw locus of line. Locus line we have to draw here. Okay, we have to draw a locus, so we call it as locus of D. So we have to draw a locus line. So after that, what we have to do, so we have to measure this length, that is from B to D. So measuring from B to D, you can cut the arc. So somewhere here you can get the arc. Okay, so after cutting the arc, so you have to join this point. Okay, you have to join this touch point, and then you can extend this. Okay, you can extend this, so the angle you can get, so that is nothing but bit angle. Okay, this is BD. Okay, BD. Now we are going to measure how much the angle we have to get here. So here okay, we have to join it here. Okay, some mistake happened here. So you can see here, 1 minute. So we have to measure exactly the length. Okay, so from BD, so look at that. So exactly it is cutted here. Okay, so joining of these 2 points is very important. Okay, then you can extend this line. Okay, extend this line. So this is where it is very important. Now you find out how much angle it is. So this is BD. Okay, so angle here I am getting around 70 degree. Okay, so you need to get 71 degree, but if you're getting 1 or 2 degree variation, that will be okay. So we get the BD length. Now we have to transfer this diagram over here, correct? So we have to transfer the diagram over here. So what I will do here initially, so with respect to this line, BD line, I am going to merge this 90 degree line. Okay, merge this 90 degree line. Okay, merge this 90 degree line and draw a straight line here. Okay, straight horizontal line. Okay, so after this, by cutting the arcs, okay, we have to transfer this diagram. So this diagram we have to copy. Okay, that is BD. Okay, BD, sorry, BC and BD. This will be having the same length. Okay, so here at this point we get it. This is BC and this is BA. Okay, so now what we do, so we have to join this. Okay, so this is our okay, so understood. Now we have to project it upward from B, from C, from this A point. Okay, so where they are merging, we have to see it. A, it is merging here, it is A dash. C, it is merging here, it is C dash. And similarly B, so it is merging here, B dash. So now we have to connect this. Okay, so this is what the problem. So you understood the procedure, right? So after constructing these 2 positions, we have to draw the median, that is BD1 first median and BD. So this is the first median, this is the second median. So we draw 40 degree angle line. After that we mark a point B. So first we will measure BD1, this median length, and we cut the arc. After we getting the arc on this 40 degree angle line, we will be drawing a locus. So we mention it is locus of D. Okay, we mention it is locus of D. So after that, what we do, we measure again from B to D. We're measuring from B to D, we will be cutting the arc on this locus line. So there is a locus line here, right? So on this locus line, we are cutted the arc. After cutting the arc, we are going to join BD. Okay, after cutting the arc, we join BD. And then we are going to extend this BD line using a scale till it is touches the XY line. Okay, after that we are going to find out angle. This is what your beta angle. Okay, beta angle 70 degree, around 71 degree you have to get. If it is 1 or 2 degree variation, there is no problem. Okay, so after that, same procedure by extending from C, from B, from BA, we'll get the final diagram. Understood, right? First two positions remain same as it is with a normal problem, but in the third position we see the changes. Okay, first we have to use the first median length, second median length. After that we have to find out the beta angle, then transfer this diagram using arc method, then finish the final position. So we learn another problem on a square plate lamina with respect to the beta angle. Okay, we will proceed with the question. So in this question, a square plate of 30 mm side, we need to construct a square of 30 mm side, rests on HP. So the first position starts from the HP plane, such that one of the diagonals is inclined at 30 degree. So you can see that one of the diagonals they have mentioned. So one of the diagonals for a square means it is an beta angle problem, right? So one of the diagonals they have mentioned means it is an beta angle problem. So is inclined at 30 degree to HP and 45 degree to VP. So you can see in this question they have not mentioned either it is resting with the on the HP plane with respect to edge or corner. So we need to find out, okay, is it resting with the edge or with the corner. So is he mentioning that the angle of inclination will be there with respect to the diagonal here. Okay, so how we are going to find out? So the angle of inclination are there with respect to the first position, it is there with respect to the edge or with respect to the corner, because you can see, say consider this is one of the square, so which is connected with the diagonal. Okay, because here in the angle of inclinations were given, say like this angle of inclination to HP and an angle of inclination to VP. Okay, so what we do, you can see here. So we'll be taking a particular look here, so you can understand easily. So you can consider this is this only. Okay, so say angle of inclinations will be there with respect to this diagonal here, like this. So you can see in this, so the angle of inclination, if it is there with the diagonal, means your first position has to be a corner here. Okay, first position has to be corner, because so angle of inclination, if it is there with the diagonal, then you can see that the first position will be there with respect to the corner only. Okay, so here both the inclinations will be there with respect to the diagonal. You can see that one of the diagonal is inclined at 30 degree to HP and 45 degree to VP. So for that, I'll just drawing a rough sketch. So if our first position, okay, just for our trial, okay, trial 1, say we have been drawn a square with respect to edge. So what will be the conclusion? Say first position it is, if it is with the edge means what happens? So the second position. So in second position we are not able to incline it with the diagonal. So diagonal, say if it is there here. Okay. So we are not able to incline it with the diagonal in the second position. So this one is wrong. Okay. This one is wrong. So let's say trial 2. Say we have been positioned square like this. Okay. This is just a rough sketch. Say with the corner. So this is our diagonal. Okay, diagonal. So we can incline it in the second position. Okay, with the diagonal like this. Okay, so you can incline it. Say we have been placed the square lamina like this. Next first position. So in second position we can incline it. Okay, with respect to the corner point, with respect to the diagonal like this. Okay, there are two ends which is connected with the diagonals. So that means our first position starts from the corner point here. Okay, this is how we have to analyze it. Okay, so I'm going to construct a square with respect to corner here. So understood, right? The two trials we have done. So one trial with the edge. So in the second position we are not able to do it with the diagonal in case if it is started with the edge. Say if we have started with the corner, means we can able to give the inclination in the second position also and in the third position also. Okay, so how to draw the square with respect to corner means, as we have learned. Okay, so what is the first, I'll be marking a reference point here. So that is what the reference point. okay, to the reference point. So using a protractor, we know the procedure. So we have to mark for 45 degree, correct? So exactly 45 degree we can mark here. So I have marked for 45 degree. So I'll be drawing an line here passing from this reference point to this. Okay, okay. Now after this, what we have to do, we have to measure 30 mm because a square of dimension 30. So measure 30 mm from the compass using a scale. Okay, so 30 we have measured. So we can cut the arc here, 2 arcs. So after cutting the arcs from this end, so you have to cut another arcs. Okay, okay, it is cutting here. Okay, it is wrong. So you can take little bit downward. Okay, so because in order to construct it correctly, so we take the reference point a little bit lower here, such that it should not merge. Okay, so we can mark again 45 degree. No need to worry. Okay, so we have drawn it. Now using the compass, we have measured 30 mm, right? Already measured it. Again we can measure it again. So it is 30. So cut the arcs. Again second arc from here. Okay, so you can join this. So this is what the square of dimension 30 will show. The dimension on one side. This is 30. Now we can mark the namings A, B, C and D. So now we'll project to complete the first position, front view. So we are able to see A dash, B dash, C dash, but D dash not visible here. Okay, now the second position. So first two positions will be same, 30 degree to HP. Okay, second position, so I'll mark A dash. I'll be marking at 30 degree. So mark at 30 degree. Okay, so it is 30 degree. We have to cut the two arcs here. Okay, first arc from this A dash to C dash, first arc. Second arc from A dash to B dash. So we can mark the naming B dash, D dash, and this is C dash. Okay, from this A to C dash we have marked the length, and we can erase the remaining part. Now we will be projecting downward. Okay. Okay. Now we can mark the namings A, B, C, this is D. So we can join this. So this is what the first two positions. So first two positions will be remaining same. Now we have to draw an diagonal line here. First we will draw for the first position diagram. Okay, so this is I'll be marking AC1, and this one it is AC. So we will not mark with the other name, the same name, but we will change it to AC1. So this is your first diagonal line and this is your second diagonal line. Now, so we have to draw the 45-degree angle line. Okay, 45-degree angle line we have to draw. So I will be drawing an angle here, taking a reference point here. So mark for 45. This is 45 we have drawn. Now first I will be marking a point, reference point here. Same procedure. Mark point A. Now we have to use this first diagonal length. Okay, AC1. Okay, AC1 we have to measure. Okay, AC1 length I have measured, and I am cutting the arc. This is AC1. So after this you can draw an locus line here, calling that locus of C1. Okay, locus of C. Okay, this is locus of C. Now the second arc length from A to C, measuring from A to C, cut another arc. So this point is C. So now we join this. This is where the point is joined, then extend. Okay, and then you find out this angle. So this angle, it is your beta angle. So here the angle I am getting, it is around 55, 56, 57 degrees. Okay, so 57 degree is my beta angle. Okay, now you see that this diagram we have to copy. Okay, this already we have drawn AC, so we have to construct this diagram here. So we already have AC, so we have to construct from A to D. Okay, this A to D, it is exactly equal to C to D. Okay, just say it. A to D length, it is exactly equal to C to D, and similarly this C to B, it is same. Okay, so these two lengths are same. Okay, in a vice versa case, so you can connect it. So now you can mark this. So this point is D, this point is B. Now we join this. Okay. So this is we have done. Now we have to project upward to complete the final position. So now we have to complete the final position. You see where A is merging. So this is A dash. Similarly we have, this is B dash. So this point is C dash, and this point is D dash. Now we will join these points to get the final position here. Okay, so this is what the final position. So today we are going to learn beta angle problem related to pentagonal lamina. Okay, so in this problem you see it, a pentagonal lamina of dimension 25, so placed on one of its corners and HP. So we know that in a pentagonal problem also first two positions will be remain same, so that's how to on the two positions. You can see that pentagonal lamina of dimension, so resting on HP with one of its corners. On the left hand side I have drawn the first position, and then inclination to HP it is given 30 degree, so that I have drawn. Now we have to proceed with the beta angle, because they have mentioned a word called perpendicular bisector. Okay, so for that first I will be drawing an angle line. Okay, So angle line I'm so 45 degree. So now we have to draw the perpendicular bisectors here from this corner point to exactly the middle point. Okay, this is M1. So first I will be taking a reference point of A, AM1. So this is locus of M. So this is the angle that is nothing but beta angle. So we have to find out this. So angle here we get it is around 55 degree. Okay, so now we have initially C to B, next D to E. So these two lengths will be same. Now we have to cut the reverse here, A to B. Okay, so this is B and this is E. Okay. Okay, now we will be extending this to get the final view. Okay. Okay, now this is A dash. So B dash we get this is, C dash will get this, and D dash we are going to get here, and E dash will be getting here. Okay, now we have to join these points. Okay. This is how we complete the beta angle in pentagon. Now we will solve the hexagonal problem on a beta angle. So first two positions are already drawn. Now we will proceed with the beat angle. You just see the question. A hexagonal lamina of dimension 25 rests on one of its own corners on HP. So we have drawn the first position. The lamina makes 45 degree to HP. So we have drawn the second position. You see it. Now you can see the question in they mentioned diagonal passing through the corner that is inclined to 30 degree to VP. So now we are going to show how the beat angle here. Okay. So before for that we'll be drawing a diagonal here. Okay, this is what the first diagonal and this is our second diagonal. So I will be writing this FC1 and this is FC. Now I'm drawing, and first I'll take a reference point here, reference point. Okay, and now I'll be marking at an angle of 30. So that's what the inclination to 30 degree. Okay, so now I'll be taking a reference of okay, a reference here F I have taken. Now first arc. So this is what the first diagonal line we have to consider. This is what the second. So first we have to consider FC1. Okay, you know, with the beat angle concept. First this length we have to consider FC1. We are cutting the arc. Okay, so after cutting the arc, so to this point, exactly to this point, we have to draw a locus. Okay, so this is locus of, this is C1, locus of C. Okay, after this the second arc length we have to cut, that is this one, FC. Okay, FC we have to measure and we have to cut on this locus line. This is your FC. Okay, now we have to join this FC line and then extend it. Okay, extend it to get the beat angle. So how much beat angle we will get it here? So we have to get so we are getting it around 44 or 45 degree. So it will be okay, no problem. We have this length. Now we have to transfer this diagram over here. We have the FC length. Okay, so first I'll be measuring this FE. So this FE length, okay, see this FE length is exactly equal to your FA. Okay, so we can cut two arcs here and here. Okay, two arcs. Similarly we have FD. This FD is exactly equal to this FE length. Sorry, CD and CB. So four arcs we have cut. Now the reverse, one arc length, it is exactly equal to C. FD, it is exactly equal to your FB. Similarly, so this FD, FB is exactly equal to FE and FA. So that means measuring one length, we can cut the four arcs. Okay, here this arc and this arc. So now this arc is not cutting. So this is FE. Okay, so now understood, right? The initial arc from FE is equal to FA, so that is exactly equal to CD and CB. Four arcs we have cut it. Then after that reverse we have cut it, that is FD exactly equal to FB. Similarly FB exactly equal to CE and CB. That's what we cut it. 1, 2, 3 and 4. So after cutting the arcs we have to name it. So this is E, this is D, this is A, this is B. So now we'll join this. Sorry, sir. Okay, so now we have to extend this. Yep. So A and A dash, so it is merging here. Okay, Similarly we will see for B. So where the B is, so here we have the B. Okay, so initially we have marked for A dash, this is B dash. Similarly series C, this is C dash. Similarly we have D dash. F3.
That's why so that last madam also told like that. So some network problem is there. Have to come from the network place. So after that, I will for every class I will ask the students. So if you have any doubt, if there is any network issue, how to ask them.
Okay. So now we will join it.
Clear. Okay. Yeah, madam. I already told you today I will share with you. Okay. Okay, thank you.
So this is what the final position. So understood, right? So first diagonal length will be cut at FC1, then locus line, then FC. So we have to cut the arc, then connect and then extend. You get the beta angle. Then transfer the diagram using arc method. Then the final position.